Welcome wherever you are. Welcome wherever you are. Teacher David here. Let me take you through this paper called ADMA Chemistry Post-Mock. ADMA, I don't even know what it means. I just got the paper on WhatsApp. So I want to take you through this paper. Remember to share, like, subscribe. My name is Teacher David. Let me take you through this paper called ADMA. I don't even know the full spellings. ADMA ADMA Chemistry Post-Mock Exam, Paper 3, Chemistry Practical. I will start with the qualitative part of it, and then later, after this video, I will bring you the quantitative, that is the mole part of it. Welcome. Remember to share, like, and even subscribe if you have not. Number 2, you are provided with solid L. Carry out the following tests and write your observations and inferences in the spaces provided. Describe the appearance of solid L. So when you are told to describe the solid, you take your solid and study the color. Which color is this solid? You can see it is white. Then you can see these are crystals. See? So when you are told to describe, you give the color, and if it is crystals, you give it is a crystal. For this one, it's a white crystal. White crystalline solid. It is a white crystalline solid. A white crystalline solid, as you can see. Place a third of the spatula full of solid L in a clean dry test tube. Heat gently, then strongly. Test any gas produced using moist red and blue litmus paper. You dip the litmus paper in distilled water, then put it on the mouth. Put them, the blue litmus and red litmus paper, put them at the mouth of the test tube before you start heating. Otherwise, if you heat then put the litmus paper, you are doing useless work. You put the litmus, moist litmus paper and the blue and red on the mouth before you heat. So the first thing you expect, if this solid contains water of crystallization, then you will observe that at the mouth of the test tube there are some droplets of water, but you don't tell us it is water. Who told you it is water? So the correct way of saying that, you say a colorless liquid is formed at the cooler parts of the test tube, or droplets of a colorless liquid is formed at the mouth of the test tube, right? So that if that is the case, then it means that this solid L is hydrated. In other words, it contains water of crystallization. So you will say solid L is hydrated. Or, when I say or, you don't need to use this one. You can say solid L contains water of crystallization. So you choose one. Either you say solid L is hydrated, or you say solid L contains water of crystallization. You pick one. Then what will happen to the litmus paper? Red will remain red. Blue litmus paper changes to red. So if blue litmus paper changes to red, what changes a blue litmus paper to red? It is an acid. So it means the gas that was produced is an acidic gas. Therefore, say acidic gas present. Or instead of writing acidic gas present, you can simply say hydrogen ions present. And that is all we need you to do. Place all solid L in a boiling tube. Add about this of this water and shake. The solid dissolve to form a colorless solution. So we are going to write the inference here. But before that, I want to take you to number 3. This is number 2. Number 3, we will do the same. It is very important for you to identify whether is number 2 organic or inorganic. Because if it is inorganic, the inference here is different. And if it is inorganic, like this part, I can say it is inorganic because when you look at the reagents, we have sodium hydroxide solution. The next I have ammonia solution, I have barium nitrate, I have lead. Therefore, this side, number 2, is inorganic. Inorganic, which tests only the cations and the anions, right? Though that is very important. Look at question 3. Question 3 is an organic solid, right? Even if when you are not told, you come here and check on the reagents that are being used. Here we are using universal indicator. We are adding acidified potassium manganate. We are using acidified potassium dichromate, then bromine water. That one tells you this one is organic analysis. This is organic what? Analysis. Therefore, in these two scenarios, this one is inorganic and this one is organic. In both, solid F would dissolve to form a colorless solution. Question 3. Question 2, the solid dissolve to form a colorless solution. So some people think, what are you going to write here? And what are you going to write here? So for organic, we would say it is polar. Organic compound, it is a polar. But for this one, it is different. So I hope the difference is now clear. If we are dealing with inorganic, here you will tell us because it is a colorless solution, then it means the colored ions are absent. Because we are dealing with inorganic, then it means if it is a colorless solution, then it means Cu2 positive, which is blue, ion 2, which is green, and ion 3 brown are absent. Absent means that they are not there. If they were there, then the solution would be blue. This one is blue, green, and brown, right? Yes. Divide the mixture in B above into 4 portions of almost equal volumes and carry out the following test. To the first portion, add 2 molar sodium hydroxide solution dropwise until in excess. Then the observation is a white precipitate is formed which dissolves in excess. Whenever you are adding sodium hydroxide and a white precipitate is formed, this white precipitate, again, when you put in the reagent in excess, the white precipitate decolorize. It means it changes from a precipitate into a solution. Why a colorless solution? It means ZAP is present. ZAP stands for zinc, aluminum, and lead. Present. These are the amphoteric present. They are present. The second portion, add 2 molar ammonia solution, dropwise until in excess. Ammonia solution is also ammonium hydroxide. So if you see that for that drop written ammonium hydroxide, we are talking about ammonia. So a white pipette is formed which dissolves in excess. Ammonia is specifically testing for zinc 2 ions. So if a white precipitate is formed and that white precipitate dissolves in excess, then it confirms that zinc is present. You see the way I'm writing the chemical formulas? So if it were you write like this, you will get 0. You will get 0. This one you print, you write slowly. If you are in a hurry, prepare to get hurry marks. Marks which are in hurry. To the third portion, add 2 to 3 drops. And let me tell you something. Do not write a white pipette. Don't use the shots. They want to ensure that lazy people will not, initially from the 2010, it went up to to recently 2024 or 2023, they were marking this one. But now they have said they will not mark. If you write PPT instead of precipitate, you will get 0. So that is how the education is changing. So please always write white precipitate, no writing shortcuts. That's how serious it is. No white PPT, and we are adding barium nitrate. First, barium forms a white precipitate with the sulfate, with the carbonate, and the sulfite. So the barium sulfate is a white precipitate, barium carbonate is a white precipitate, barium sulfite is a white precipitate. But now we have been told that no white PPT. So if it is no white PPT, then it means this one are absent. There's nothing else you write. This one you will write present or absent. If you are adding this, a white PPT is formed, a white precipitate is formed, then these are present. Check the way I'm writing the chemical formulas. I am not in a hurry. I'm not in a hurry, sorry. But if you are in a hurry, then prepare. See the way I'm writing the chemical formulas. You come here, you write as if you are running away, as if you want to be a doctor. You see? Present if the white precipitate is formed. Because there is no white precipitate, it is absent. No white precipitate, these ones are absent. Don't include chloride. Chloride is only for lead. Barium chloride is a colorless solution. Please remember that. To the third portion, add 2 to 3 drops of lead to nitrate. A white precipitate is formed, and this white we are told to warm. So you need to include in your observation what happened when you warmed, right? So a white precipitate is formed which dissolves on warming. This white precipitate, when it was formed, it dissolved to form a colorless solution. So this is what I want you to understand. Lead forms a white precipitate with the sulfate, the sulfite, the carbonate, and the chloride. So lead chloride is a white precipitate. Lead sulfate is a white precipitate. Lead sulfite is a white precipitate. Lead carbonate is a white precipitate. But this one, when you warm, the white precipitate dissolves. That's why we say in Form 2 that all chlorides are soluble. All chlorides are soluble except lead chloride and silver chloride. Then we give you a note that lead 2 chloride is soluble when warming, after being warmed. On warming, it dissolves to form a colorless solution. So it means that this one is present. This one, if they were present, they cannot dissolve to form a colorless solution. Now, you could say, why didn't I include the sulfate, and the carbonate? Why will I include it here, yet here, from the first one I've said it is absent? So if it is absent, where is it coming from in the next one? It will not be there. So it is not coming here because it is absent. So it is this one which is present. Let's move to organic. Number 3, you are provided with organic solid F. Carry out the test below. Write your observations and inferences in the spaces provided. Place about a half of solid F on a metallic spatula. Heat over Bunsen burner flame. So the solid melts and then burns with a yellow sooty flame. If a solid and we are dealing with organic burns with a yellow, then that means it is unsaturated. It means it is unsaturated. So if it is unsaturated, you don't write for us unsaturated here. You give us the functional groups of compounds which are unsaturated, and those, we have 2 of them. The double bond. Make sure this carbon is surrounded with 4 covalent bond, triple bond. Put another here to make sure that each carbon is surrounded with present. So I saw some students being confused. If I put it like this, still there's no problem, that is still okay. If you do like this, like this, still it is okay. It doesn't matter where this dash is, so long as it is on this side of the carbon. So either this, or this is okay. Even this one you can write as C triple bond. Instead of putting it here, you can put it here. It is okay. Now we are putting the remaining solid in a test boiling tube, adding distilled water. Then we said about this one, solid F dissolved to form a colorless solution. Because we are dealing with organic analysis, then it means this solid is polar. When in organic chemistry, when we are talking about organic chemistry, a substance which dissolves in water and it is an organic compound, it means that compound is polar. So you say solid F is polar. Solid F is polar organic compound. You can even add that. It is not necessary. You can just write polar, organic polar. Why am I including organic? Because I was told it is an organic. But if they said solid F, although I'm dealing with organic, you simply write polar. Divide the solution in above first portion, add 3 drops of universal indicator, and when you check the pH scale with the you check the colors with the pH paper, the scale that you are given. When you compare, you realize that the pH matches, the color in your test tube matches to the color on the pH scale or 5. So 5, it is an what? A weak acid. Then you simply write here weakly acidic. If it was 1, 2, 3, you write strongly acidic. If it was 7, 8, weakly alkaline or weakly basic. 11, 12, 13, 14, strongly alkaline. To the second portion, add 3 drops of acidified potassium manganate 7, which is purple. Then the purple acidified potassium manganate is decolorized. In other words, we are saying the color of acidified potassium manganate changes from purple to colorless. If that is the case, then there are 3 things which are present: the double bond, or the triple bond, or the ROH is present. So don't say the ROH was not here, so you are contradicting. There's nothing here like that. This one is organic analysis, therefore this one tests for these 3. These of them. Don't say that it was not here. Now you don't want to write it here. Don't do that. It must be written. To the third portion, add 3 drops of acidified potassium dichromate dichromate 6. The color of dichromate 6 is orange. So orange acidified potassium dichromate remains orange. It means the color persists. Nothing happened. Don't write nothing happened. The orange color remains orange. The orange color of acidified potassium dichromate remains orange. So if that is the case, this one is always usually expected to change to green. After being warmed, it is expected to change to green, indicating the presence of ROH. Only it is used to test for an alcohol. But now it did not change. It means the ROH is absent. ROH is absent. So the fourth portion, add 3 drops of bromine water. Bromine water is decolorized, then it confirms that the double bond, the triple bond is present. That is what it means. Share, like, and comment. Thank you very much. Wait for after I will put the link for the mole of this one will be in the link after I finish preparing it.